Hey, it's great. So if you're watching this video, you probably already found this post. It looks different because it's the teacher version and I'm editing it still. But you'll notice you watch this video, the intro video, and you work on page 7 through 9, which if you don't remember what page 7 or 9 is because you don't have the worksheet packets, the one I printed off, it might not be numbered. I don't remember if I gave you a numbered version or not when I scanned it. You can just take a look at the PDF here in a minute. And then the one that says Untitled Doc should say what worksheet pages 7 through 11 once I post this and it updates. But that's where you're going to take a screenshot. Probably not a screenshot because I don't know if you can do it on the computer. What do I mean? A webcam thing, a photo. That's the word. Whether you take it with your webcam or your phone, I really don't care how you get a picture of it. You just have to get a picture of each page, slap them in this document, or I can't do it on here, but there's a way to attach more files to your assignment. That works too. But let's take a look at these two things here. So the main one is your worksheets, which are pages 7 through 9. That's the three that specifically are on the whole rock cycle. And you might have to, and I'll pull this up when we get to that point, but you might have to use the ID table a couple times for some of the questions. So let's take a look. So page 7 and 9, 7 through 9 are, the first one has the rock cycle plastered on the page. So a little bit more well labeled one than our notes, I guess, because we didn't label all the ones that were in here. But for the most part, it's the same. They added a few more things in here. It's a little bit fancier than ours in our notes, but it's a good rock cycle. So you're going to use that to, or your notes, I guess, doesn't really matter, to tell me and answer the questions here. So like, what are the three classes of rocks or three big categories of rocks? You're going to look at the arrows, which represent processes. So it's going to give you questions like this one here, follow the arrow from sedimentary to metamorphic rock. What process is necessary to change from a sedimentary to a metamorphic? So you're just looking at the rock cycle, saying what has to happen when you go from sedimentary to metamorphic. So it is important to know that the way the arrow is pointing, like this one here is pointing to metamorphic. That means you started at a sedimentary and you're changing into a metamorphic. If it goes the other way, you're going from, oh, this one here is actually like a cycle. It's saying metamorphic rock goes through the same process again, and it might change again. Though, so if it kind of loops around, it means it's circling around and it's going right back. It's going through the same process again. I know those types of arrows weren't on our notes, but I just wanted you to see that, like, the sediments can erode, they can uplift and weather and erode, and they can still stay sediments. So there's some cycles or cyclical arrows that just kind of loop around and go back to the same type. Just make note of that on here. But then there's ones that obviously you can make magma solid or you can melt it back into magma. So there's kind of three types of arrows. One that goes forward, one that goes backwards, one that loops around like these ones here, or this one over here. So just be aware of that. So you're going to be looking at those arrows, answering all these questions. All of these ones come from just the rock cycle diagram. You can use all of it. All of them will come from this one. If you use your notes, oh well, it'll get you there too. So that brings us to the last page here, page 9. How you can tell that this is page 9, if you can see it on here. Where does it tell me? It shows me when I'm not screen recording, but it's not showing me currently for some reason. Usually with PDFs, it has a part where it says page 7 of however many pages there are, and it usually pops up right over here when you're scrolling. I don't know why it isn't right now, but this is the 9th page in our packet. It's on the rock cycle as well. This is the only one that you might have to go back to Classroom and pull up this ID table for. Some of them you can get from your notes. Some of them weren't specifically in our notes. They're in the ID table, which has a bunch of different types of rocks in it. So the key ones for a lot of this information here. Skip over the first page. It's on minerals. Don't need it. So this is the big one here for being able to tell if it's a sedimentary rock, an igneous, or a metamorphic. So if you just randomly went out, picked up a rock laying on the ground, and you wanted to figure out which type it belonged to, you would kind of look at these things. So sedimentary can have fossils or large sediments. So if you see sand particles, if you see little tiny pebbles in a rock that are like stuck there, it's a sedimentary rock. If they feel rough or gritty or chalky or just kind of dirty, not actual dirt because it's literally a dirty rock, but if you wash the rock off and it still feels kind of gritty, they call that clastic in the geology world. It's more than likely a sedimentary. If it can absorb water, I should actually try to find a rock for my notes that can absorb water. It is a sedimentary rock. So that fact right there actually helps you know what kind of rocks can store oil too, like crude oil for refining into engine oil, gasoline, jet fuel, all that stuff. Like in North Dakota where I used to live, it was shale, I believe. So shale is a bunch of clay particles stuck together, and they have little tiny pores in there that let water flow through it, like for aquifers and your water supply. Like if you live out of town like I do, you actually pump up water from the ground, essentially. It's in layers of rock, sedimentary rock. Right. No naturally formed crystals. So if you see a crystal of any kind and it's not a chunk of some other rock that's shoved together and glued in there, it isn't a sedimentary. So if you have any kind of crystals that aren't other chunks of sediment, it's not a sedimentary. And then igneous, think granite. If it's got large crystals that are kind of randomly smushed together, they're not perfectly formed crystals like a diamond or a ruby or things like that, you are looking at an igneous rock. If you have very small crystals, it's also an igneous. It's just a different kind, which we'll talk about in our notes on Wednesday. And this is the key here. The crystals interlock. So you can't chip away at the crystals to get like a nice little gemstone out of it. They cooled and formed around each other, so they're all interlocked and you can't like pull them apart. Some are glass-like, like obsidian. Some have large air pockets, like the one that I shoved in the 5-gallon bucket and it floated. And they may have shiny crystals. Okay. Metamorphic, key thing here. They can be very shiny and glittery. I think I showed that like with marble. We have the chalk or limestone, and if it goes through a metamorphosis, if it heats up and gets a lot of pressure on it, it forms marble. And the marble is also white, but it had lots of shiny crystals, and it was a little bit harder than either of the other two as well. The other big thing with metamorphic, besides it being kind of glittery and shiny, is it can have, a lot of them have distinct layers. They're foliated. So if it mentions anything about a rock looks like it has layers, huge key that it is metamorphic. And then the difference here with the crystals is you will form a lot of perfectly shaped crystals. Like I had some schist, I think, once at my other school that had like little rubies, like looked like you could chip them off and put them in a ring or one of those little birthstone pendant things. If they form crystals in a metamorphic rock, they're going to be like cool. Think Mary's or Miss Raymond, however she goes by for you guys. Think about the ones that she has up on her desk that I'm jealous of. I wish that was on my desk because that's just pretty cool. Those are perfectly formed crystals, if you will. Okay. And then ignore the field trip stuff. I did a field trip once where we went out to a place that had a bunch of different rocks just laying on a beach, and we had to try to find some. So that's why that was there. Otherwise, the reason why you might have to go to the last 3 pages is a couple questions on here that bring up specific kinds of rocks. So it says gneiss or gneiss is an example of which one of the 3 rocks. So you go to these last 3 pages here and you look for gneiss. And each page corresponds to a different type of rock up at the top there. This page is sedimentary. This one's igneous, and the last one is metamorphic. So you just use these to find the different types of rock. Some of them have pictures, some of them have descriptions. And this is essentially what we would have used in class to kind of do a lab, I guess, of trying to figure out what the heck rock I gave you. So we'll do that a little bit. I hope to have some of the chemicals I need, some of the stuff I need to grab a random rock and walk you through the whole identification process, at least so you see it somewhat online. But otherwise, that's why you would need to use this ID table. Some of the questions on that last page come from this information on like how you know which type of rock you have in general. Some of them, when they mention a name of a rock, you use the other 3 pages at the end. Otherwise, once you get that done, remember to get a picture and paste it into this document that's in the assignments, or you can attach it as individual JPEGs or whatever on the assignment as well. So with that, good luck. Let me know if you have any questions.